let's go ahead and try a little bit harder of an example. So let's draw a more abstract shape. So go ahead and just start here. Let's make it 7 tall on the left. 3, 4, 5, 6, 7. Okay, and then we're going to make it 7 wide, make it almost a square. 2, 3, 4, 5, 6, 7. Okay. Let's say it goes to the right 1 at the top. And then we have a small 2x2 square sticking out at the top here. So we'll just draw a quick 2x2 square. Then what else? Okay, let's say it goes all the way to the end over here as well. Let's say it only goes 2 up here on the right side and only 1 down here on the left. And then let's say we have a small semicircle with a radius of 2 sticking out, or coming in, I should say, inwards here. So I'll draw my 3 little lines here and I'll connect them with an arc. So we got ourselves a little semicircle. Let's call it a scale of 1 to 1. Just to keep our lives simple, let's go ahead and get started calculating the centroid of this shape. So let's call this big square, which is a 7 by 7 square. Let's call that shape 1. Let's make this tiny square here shape 2. And let's make this semicircle, this third shape that we're cutting out, this would be a subtraction. Let's make this one shape 3. And so the area of shape 1 is pretty obvious. It's just 7 by 7. So that is what? Just 49 inches squared. And the area of shape 2 is even easier if you look at just a 2 by 2 square, right? So that's just an area of 4 squares, 4 inches squared. And the area of our circle here, a little semicircle here, well, the formula for the area of a circle is just, we'll call this area 3. Formula is pi r squared. But if you look, this is a half circle, so wouldn't the formula be pi r squared divided by 2 to cut it in half? So that's pretty easy. We know what our radius is. Our radius is 2, so we just type in, okay, pi, and then we say, okay, r, which is 2 squared, and then whatever that is, we divide that, I'm going to convert that, divide that by 2. So we get 6.3 or 6.28. I'm going to go ahead and round that off to 6.3 inches squared, just to keep our math simple. And so next, let's find the centroid of each individual shape. So shape 1 in the x direction. Well, let's go ahead and actually, let's mark ourselves a little reference point here. We mark ourselves down here. This can be our reference point. Just a good standard reference point is the bottom left. And our centroid would be right here in the center. So at 7, we'd go 3.5 from our reference point. So 3.5 is right here. This can be our x1 distance to our centroid. Okay, our x distance to our centroid 1, I should say. So that'd be located right here in the middle, and then we can go ahead and assume, since it's 7 by 7, that the y distance is also 3.5, so that will be our y distance to our centroid 1 from our reference point. So I can go ahead and label these, okay? We can say our x distance 1 is 3.5 inches, and our y distance is also 3.5 inches. Now, our shape 2 centroid would clearly be right here in the center of this square, which is just 1 and 1 from each side, but that's not where we're measuring from. Remember, we're measuring from the reference point to keep everything consistent. So that would be an x distance of 2 from our reference point. So I'm going to say x2 is just 2 inches from our reference point, okay, equals 2 inches. And what about our y2 distance? Okay, so we go all the way up to here, actually even further than our original shape. And what is that? That's 2, 4, 6, 8. So our y distance, I'm going to go ahead and label this as y2, but it is simply 8 inches. So y2, I should say, equals 8 inches. And let's go ahead and add a 2 on our x as well. But the circle gets a little bit more confusing. So okay, we know the centroid is going to clearly be in the center of our circle in the y direction, but in the x direction, it's a little bit stronger pull to the right than the left because we have more space cut out on the right than on the left. So it's not going to be right in the center at 1 from this edge. It's going to be a little bit more to the right because there's a little bit more in the right than there is to the left. So maybe about right here. And we can actually calculate that number. We have a formula for that, as you might recall. So let's go ahead and figure that out. It's x3. What would that be? Okay. Well, the formula is 4r divided by 3 pi. And we know r, so that's just 2, right? And okay, so let's plug this into our calculator. Let's hit numerator over denominator. We'll type in 4 times r, which is 2, so times 2, divided by, we'll go to the bottom, 3 pi. This is the formula for the direction of a half circle of the centroid. And what do we get? We get 0.84. I'm going to go ahead and round that up to 0.85, but that's a distance from this edge right here, not the distance from our reference point. So if this is 0.85 from our edge here on the right, wouldn't it be the opposite amount? So subtracting from 7, so we can just subtract from 7 to get it. From our reference points, that this whole square is 7. And what do we get? We get 6.15. Ignore that negative. I'm doing this backwards. So we get 6.15 from our reference point, 6.15 inches. And then our y distance for our centroid 3 is incredibly easy. If you look, it's just right here in the center here. So it's 2, 4. So y distance is just simply 4. So from there, I'm going to go ahead and paste in our x and y formulas and go ahead and start solving for them. So a formula says the sum of all x's or individual x's multiplied by the sum of all areas, or x's times area, sum of all those. Okay, so what is the first one? We know the first x is just 3.5, and we're going to multiply that by its area of 49. Okay, and we're going to add that to sum of all the individual x for shape 2, which is just 2 times its area, which is just 4. Then we're going to add that to the x from our reference point. Since it looks like I haven't actually labeled that. So x3. So our individual x distance to our centroid from our reference point, which was 6.15, multiplied by its respective area, which is just 6.3. We're going to divide that by the sum of all areas. So that's just 49 plus 4. Let me get the colors here to keep it color coded. Plus the last area is just rounded off to 6.3. And so to calculate this, let's go ahead and type it in our handy dandy calculator. Let's put it in numerator over denominator to keep our lives easy. Let's say 3.5 times 49. Or plus 2 times 4. Plus, oops, don't hit enter. Let's go back and see if we can, yeah, let's, there we go. Plus 6.15 times 6.3. 6.3. And then on bottom, we'll just have 49 plus 4 plus 6.3. And let's see what we get. We get a number of 3.7. Let's stop it for a second and think. Does that answer make sense? So hold on. We got a shape that pulls the centroid to the left a little bit. We've got a shape that draws towards the center, and we've got a cutout. We've got a cutout on the right that wouldn't pull it to the right, but to the left because it's missing. And now we have something, we have a centroid in the x direction that apparently is towards the right of the original centroid. That doesn't make any sense. Shouldn't all three of these x's be pulling, or I'm sorry, this one pulls it towards the center. These two x's pull it to the left. So why doesn't that make sense? We can check our work and we see, oh wait, this is a negative. We forgot to plug in a negative for our 6.3. We forgot to plug that in right here. We forgot that this area is cut out, therefore this is subtracted. This is a subtraction method part. So it's a combination of addition and subtraction. So let's go back and replug that in our formula. So we hit enter and we go back and we find that part of our equation. So let's scroll up. No, scroll to the right now. And we're going to insert right here at 6.3. You can find it in our calculator. We'll go to second insert, a little negative symbol right here, negative 6.3. And let's hit enter again. Let's see what we get. And let's try that one more time, because actually, now that I think about it, we forgot to add the negative 6.3 on the bottom side, didn't we? So let's go over, and let's add this as a, or make this positive, a minus 6.3, and let's hit enter one more time, and that answer makes a little bit more sense. The answer of 3.01. So let's go ahead and cut this out, and let's put a more correct answer, 3.01 for our x. And again, if you think about it, that makes sense that it would be pulled slightly to the right, I'm sorry, to the left, because we've got a leftward pull from this shape, and we got a, well, this is a rightward pull, but it's cut out, so that will be a negative cutout, or negative pull, which means it's going to the left. So our x should be about almost exactly 3 for our x distance. And then for our y, we just plug in our same numbers, or we plug in our new numbers, I should say. Our y1 is still 3.5 multiplied by its shape, which is 49, or its area, I'm sorry. And then we've got our 8-inch y distance times its area, which is still 4 for our shape 2. And then we have a new y distance of 4 inches multiplied by its area, which was 6.3. Let's not forget that negative this time. Actually, let me make this a negative up here since it was supposed to be. We made that little mistake. And then on bottom, we're just going to plug in the same numbers as before. It's just 49 plus 4 and then minus 6.3. And then let's just plug that into our calculator real quick. So we'll start a new one, numerator over denominator. We'll say 3.5. Let's type a little bit faster on my keyboard here. 3.5 times 49 plus 8 times 4 plus 4 times negative 6.3. 4 times, and I'm going to make sure I hit the negative button, 6.3. And then on bottom, we'll just say 49 plus 4 minus 6.3. Let's see what we get. We get a y of 3.8. Let's look at that again. Does that answer make sense before we move on? Would it make sense that it would be pulled, the centroid would be pulled slightly up? Well, if you think about it, this shape would pull it up quite a bit, whereas this shape, since it is up, but it's a cutout, it's up just the tiniest bit, but it's a cutout, it'd pull it down a little bit. Now, this is a smaller area, this is a bigger area. How much bigger? Well, it's about 50% bigger. So it's going to have 50% more pull. But this is a further distance, so it has a higher average, okay? So we say 3.8, well, that's just about right here, which makes our total centroid, hold on, let's go ahead and dot it out, where they meet, which is about right here. Let's go ahead and make sure I get my right color here, make it the original. The total centroid would be an x distance from our reference point of almost exactly 3.01, and our y distance would be from our reference point would be 3.8 for this shape. And so as you can see, in this shape, we had an addition method part to it where we added our shapes because we had 2 shapes to add. And then we had a shape we had to subtract out of it. And each shape pulls the centroid, the total centroid, a certain direction based on how much area they have and where they are located. If a shape's further away, then it's going to pull a little bit harder. If the shape's a little bit bigger, it's going to pull it a little bit harder in the X or Y direction.